Hi, I am Varun Joshi and welcome to day 52 of our Certified Kubernetes Administrator 2025 course. This Gateway API lecture is divided into two parts. In part 1, we will focus on the foundations. We will recap what we already know about Ingress, identify its gaps, and then explore how the Gateway API addresses those gaps and challenges. We will walk through the core resources of Gateway API like gateway class, gateway, and routes, and see how the actual flow looks like. In part 2 of this series, we will get hands on with a demo using Nginx Gateway Fabric to put these concepts into action. So, without any further ado, let's get started with part 1. Now, before I start, there are certain prerequisites for this lecture. So I will go to my browser, and from here I'll go to my repository. I will zoom in a little, and then I will go to CKA certification course 2025. From here, I will jump on to day 52, which is today's lecture. And then from the table of contents, I'll go right to the prerequisites. See, I want you to first understand what Ingress is and how it works, because Gateway API can be thought of as an advanced Ingress. What they have done is they have taken out, or they have jotted down all the limitations that there were with Ingress and built Gateway API. So in order to understand Gateway API fully, you first must understand Kubernetes Ingress. I have a 3-part series on this channel. If you are short on time, I would highly encourage you to just watch day 49, where we cover the theory of Ingress. And if your interest and confidence builds, then there is no one who is stopping you to learn more and watch day 50 and day 51 as well. Another set of prerequisites are: you should understand what are custom resources and custom resource definitions. So why I want you to know these is because if I go to my terminal and then I will run kubectl API resources, and if I grep for, let's say, Ingress, then I will see that Ingress and Ingress classes are here. But if I grep for gateway, which is today's lecture, Gateway API, I do not see anything. This is because Gateway API is not already there in your cluster by default. So it does not come with the native Kubernetes implementation. How it works is these objects that are related to Gateway API, and we'll see what those objects are. They are installed as CRDs. And what are CRDs? CRDs are custom resource definitions. Hence, I want you to understand what custom resources are and what are custom resource definitions. So to have that complete picture, you can watch day 39 of this course. And then I have also written that you must understand Kubernetes operators. Now, operators are closely related to custom resources and custom resource definitions, and how they are, you will learn in day 40 of this course. So I would highly encourage you to have this knowledge. Now, Varun, can't I watch it without this knowledge? You can, and you will understand a lot of things. But I always thrive for that aha moment. You will only get that if you understand all these concepts. So, with that said, let's get started with this lecture. I'll go to my diagrams, and the first point is what we already know about Ingress. We know that Ingress natively is the keyword here, supports HTTP, host based, and path based routing. Second is advanced features come from controller specific annotations. What is this, Varun? Now, I want you to clearly understand that when we were dealing with Ingress, we dealt with both path based and host-based routing. And host-based routing is also called subdomain-based routing. What we learned was in the spec section, understand, in the spec section, we defined the paths and hosts. Rest everything, what the load balancer should look like, we defined those things in the annotations section. What are annotations? Annotations are there so that you as a cluster administrator can have some informational messages, and these informational messages can be consumed by your fellow engineers, or they can be read by third-party tools. And in our example, we specified the configuration of the load balancer that we want in cloud in the annotations section. And what happened under the hood was there was a controller that was constantly watching the Ingress resource, and based on these annotations, it configured the load balancer. I want you to understand very clearly that Kubernetes in itself does not really care what you have in annotations. So for example, if something is wrong and you applied this manifest, if there is an error somewhere, Kubernetes will not throw an error as long as you have adhered to the YAML syntax. Because we know that when you apply a manifest, there is a level of verification that is performed by the kubectl client, and then there is a second round of verification that is performed by the API server, and both of these will not give an error if there is a problem with your annotations, because annotations, like I said, are just for informational purposes, and Kubernetes will not care if you have spelled this traffic port wrong or you have write some gibberish here, as long as you are adhering to the syntax. But what will happen is the load balancer is watching this. If there is a misconfiguration here, your load balancer will not be configured the way that you like, because you have not properly configured the annotation. So understand this point. Kubernetes natively could care less about what you have in annotations, but the third-party tools that are looking at your annotations to configure something somewhere. Now, load balancer is our example here. It could be anything. It could be your CI/CD tooling and all those things. They care about what you have written. If you have misspelled it, they won't work as expected, but Kubernetes could care less. Now we understand that. So let's reread this point again. Advanced features come from controller specific annotation. So the crux is the Ingress only supports path and host based routing by default. All these other things, the certificate, the SSL redirects, the health checks, the target type, the load balancer name, the schema, all of these things are coming from your load balancer controller. And these settings, these annotations hold true for AWS's load balancer controller. Each implementation, if you are using Nginx controller for your Ingress, then it will have different annotations. We understand that from our previous lectures on Ingress. Now let's go back here again. Annotations vary by vendor and aren't validated by Kubernetes, and this is a key point like we discussed before. For example, if I go to my browser, here I have opened the annotations that are at your disposal when you are using AWS's load balancer controller. But if you are using Nginx Ingress controller, HA proxies Ingress controller, Traffic's Ingress controller, then the annotations will be different. At its core, the Ingress object only supports path-based and host-based routing. Rest of the bells and whistles are coming from annotations. That is the crux part here. All these features are not natively supported by Kubernetes. Ingress natively only supports path-based and host-based routing. And this is not sufficient for us, as we already know. Now let's go back to the diagrams and see what I want to discuss next. The next is what's missing in Ingress. First point is native multi-tenancy or namespace level route isolation. Now let's scroll to the left and see what is happening in this diagram. Firstly, before I discuss this, I will go to Visual Studio Code. Rather, I would go to terminal to show you one thing. If I talk about Ingress, you see true here, and this column is for namespace, which implies Ingress is namespaced. Hence, if I go to my Visual Studio Code, I have this Ingress defined in application1 namespace. But Varun, why is this a problem? I told you in our Ingress lectures that load balancers, they incur a cost, and you would be using a single load balancer to expose multiple applications. Now, these multiple applications could reside in their own namespace, and if they reside in their own namespace, their services, respective cluster IP services, will also reside in their own namespace. Then how would you define that in your rules? Because Ingress is namespaced, and here you can only reference the services that are part of the same namespace. You cannot reference a service that is from another namespace. This is a problem. If I have 10 applications to expose, I cannot deploy those 10 applications in a single namespace, because I want to leverage the load balancer that is spun in the cloud. That I cannot do, because firstly, we want isolation in our applications. We want applications to be deployed in their own respective namespaces, and this cannot be achieved using the native Ingress resource, because this native Ingress resource is namespaced. So if I go back to my diagrams, you see the same thing here. There are multiple applications in the same namespace which are accessing your Ingress resource, and this will work fine. But again, we want our applications to be deployed in their respective namespaces. Second problem is this: if you have multiple applications which are using the same Ingress, then there is one more caveat here. All my developers will have to be given access to this Ingress resource, and I don't want application 1 developers to be messing around with the configuration that app 3 developer or app 2 developer has done. I want clear delineation between what all actions can be performed by what all resources, and here that is impossible to achieve, because I just have one Ingress resource and then 3 different applications who want to access that Ingress resource, and all these developers will have to be given access to the complete Ingress resource. I do not have an option via which I can say that app 1 can only see or modify this section under the spec section. I cannot do that. I have to give access to the entire Ingress resource to all the developers that belong to app 1, app 2 and app 3. This is not something we want. Again, let me tell you one thing, one very interesting thing. Both these limitations, there are different controllers and they have done a few things to get over these limitations. So if I talk about AWS's load balancer controller, they have introduced something called Ingress groups, and using Ingress groups, you can do all these things. You can have your application in different namespaces and still use the same Ingress, same load balancer. That is possible. But again, that is possible using a combination of annotations, but it is not natively supported by Kubernetes. Hence, this sort of design is not natively supported by Ingress resource. But keep that in mind. that different controllers may have a solution via which you can achieve this level of segregation. Now, second point is support for TCP, UDP, and gRPC. Currently, the Ingress resource only supports HTTP and HTTPS, of course. However, TCP, UDP, and gRPC are not supported. gRPC is a high performance open source protocol for remote procedure calls. The expanded form for gRPC is Google Remote Procedure Calls. It is Google because Google is the one that made this protocol and then made this open source. It enables different systems to communicate with each other, even if they are written in different languages or reside in different platforms. It uses HTTP2 under the hood. This is just for your information. Third point is first class features like Canary. Now, Canary is if, let's say, I am doing an upgrade or I want to test different versions of my application, then what I can do is I can tell that 30% of the load should be catered by, let's say, this deployment, and 70% of the load should be catered by this deployment. And you will often hear terms like traffic splitting or weighted routing. They all imply the same thing, that the certain section of users, let's say 40%, should go to this service, 60% to this service. Now, why this is done? This is done to take majorly feedback from your users. Let's say you rolled out a new feature and you want to know how users feel about that feature. You are not that confident, or you are still in your that testing phase, hence you have not done a full rollout. You have only done it for 20% of the users, so that those 20% can land on the new feature and test your new feature and give you a feedback on how it works. And there are different other deployment strategies, but for now, Canary is this. Then there is SSL redirect. SSL redirect, we also saw this in our demo of Ingress. Whenever request comes to, let's say, HTTP, it is automatically directed to HTTPS, which is TLS or SSL. Then there is rewrites. What are rewrites? As the name implies, it will rewrite the path, for example. So if you are accessing myapp.com/app1, and if someone accesses that, you want to rewrite this to myapp.com/app1 my page, then it will do that for you. Rate limiting is in a minute, a user can only send 100 requests. So things like this are not natively available with Ingress. These features are supported, but they are supported using annotations, which are dependent again on controller, how the controller is implementing them. The last point is portability. Annotations are vendor specific and not spec validated. And we know that. So for example, if you are today using AWS's load balancer controller and tomorrow you want to migrate to Nginx's Ingress controller, then you will have to change all your annotations because these annotations are vendor specific. Now, with this information, let's start our discussion on what exactly is Gateway API. Gateway API is next generation Ingress with multi-protocol support. Remember, previously only HTTP was supported by Ingress, but this supports TCP, UDP, and gRPC as well. Next generation Ingress with multi-protocol support, role separation, and we'll see what role separation is in a little while, and portable traffic management. So, Gateway API is your next generation Ingress. Native multi-tenancy on namespace level route isolation, support for TCP, UDP, and gRPC routing, first class features like Canary, SSL redirect, rewrites, and rate limiting are supported out of the box. Now, these 2 points are new. Not a built-in resource, enabled via CRDs and requires a compatible controller to function. Understand, we discussed this in our operators section and also in our CR and CRDs section. If you want something to be constantly checked whether it is working fine or not, it requires a controller. For example, if you are dealing with vanilla Kubernetes, you have deployment, and deployment has a controller. Why there is a controller? Because we want the desired state should match the current state. If I said I want 5 replicas, then 5 replicas should always be there, which is the reason we have deployment controller, replica set controller, and other controllers to ensure the desired state matches the current state. Hence, with Gateway API as well, you will be dealing with a controller, and that controller's responsibility will be to ensure that whatever you have configured is adhered to. Last point is developed by Kubernetes SIG. SIG is special interest group, and this group within the Kubernetes community takes care of anything related to the networking API. So Ingress, Gateway API, all of these are taken care by Kubernetes SIG, special interest group, and Gateway API is also taken care by them. Now we have a fair understanding of what is Gateway API. Hence, I want to discuss the most critical part, that is Gateway API's API kind. Now, I told you that when you want to configure Gateway API, what you do is you install CRDs. And when you install CRDs, then you can create custom resources using that CRD, because in essence, what a CRD is a template that must be adhered by the CR that is created using that CRD. So let's move down, and here I have Gateway API has 3 stable API kinds. First is gateway class, then there is gateway, and the third one is route objects. Now this one has multiple. So for example, if you are using HTTP, which we will be using in our demo and in our discussion, because HTTP is the most popular one, then you will have the kind HTTPRoute. If you have TCP, UDP or gRPC requirements, then you will have something else, which is why I have written here route objects. Here I have written gateway, which is the exact kind of the object that you will create. Then there is gateway class, which is the exact kind of object that you will create or your controller will create. And we'll see this segregation in a little while. Now, what Kubernetes has done is they have given these roles, and this is good. So for example, the gateway class is the responsibility of infrastructure provider. Now, who is the infrastructure provider? If you are on cloud, that infrastructure provider would be AWS, GCP, Azure, or your cloud provider. If you are on premises, then the infrastructure provider will be you. For example, if you are on cloud, the load balancer that gets provisioned is configured by you, but in essence that is responsibility of the infrastructure provider. Hence what they have done is, if I go to the documentation, they have clearly called out that there are 3 roles: infrastructure provider, cluster operator, and then finally the application developer. So let's go back to the diagrams, and here the gateway is the responsibility of the cluster operators, and route objects is the responsibility of application developers. Now, these two in real world implementation scenarios is an overlapping role. There could be scenarios where DevOps engineers are handling both of these, and in most of the use cases I have seen that it is the DevOps engineer or the Kubernetes administrator who is taking care of both of these things. But again, these are project specific and may change. Maybe your compliance requirements want that a cluster operator should not be able to make any changes in the routing rules. in that scenario, you will have proper segregation that only application developers have the authorizations to make changes in the route objects. Now that we understand why we said this role separation, so let's understand this further. Let's zoom in into gateway class. Now what I have done for this lecture is I have right away introduced these YAMLs to you so that you can start creating the mental picture from this initial stage itself. And this is something that we also did in our storage lectures where we were understanding storage class. So whenever some topic is complex, it is better if we have the corresponding YAML in front of us so that we can create that mental map. So let's discuss gateway class. Logical template for gateway configuration and features. If you remember, when we were dealing with storage classes, we defined whether a storage class is associated with GP3 or IO1 and so on. And we also defined a provisioner. So if I go to day 27 here, and this is my YAML for storage class. So here I was saying that I want a GP3 volume, and here I was saying I want an IO1 volume. And then there was a provisioner here, and this provisioner was taken care by our CSI drivers that we configured, and we did this in our stateful set lecture as well. So now I want you to directly correlate this with what we are doing on this screen. So what you see here is we have a controller name. What we are saying is this gateway class is looked after by a specific controller. What that controller is, where that controller is, we will see in the next diagram. But for now, understand, in the storage class there was a CSI driver that was looking at that storage class and then taking some actions based on what PVC was created. Similarly, in here, this gateway class is being watched by a controller, and based on what the specifications in gateway is, a corresponding load balancer is spun. Now let's understand what the next point is. If you have any doubts right now, it will clear up as we discuss all these three. Second is binds to a specific gateway controller implementation, and we will see that in this diagram this class is binded to Nginx gateway controller. Referenced by gateways does not create runtime resources. Now storage classes on their own will not create any resources for you. What happens is when there is a pod that wants to use certain amount of storage, there is a corresponding PVC that defines that I want storage from this storage class, and when a pod is spun and pod uses that PVC, a storage is automatically created in cloud for you. This is what we saw in our stateful set lecture, and also we discussed this at stretch in our storage section. And why I am mentioning this here, I want you to correlate these things with things that you already know. So what I am saying in this point is there is a gateway. This gateway is referencing the gateway class that already exists. So if you see here, it is saying the gateway class name I want is Nginx, and based on this the controller will check, okay, this gateway is referencing that gateway class. Oh, I am responsible for that. And how it knows that the controller is responsible for that gateway class? Because gateway class has a field that says controller name, and this is the name of the controller. So hence, referenced by gateways does not create runtime resources. This in itself is not creating any resources. Holds provider specific parameters and default policies. If you have a gateway class for Azure, it will have different parameters. If you have for AWS, it will have different parameters. I want you to keep this in mind. These are specific to the controller implementation, to the gateway API controller you are using. If you are using Nginx Gateway Fabric, then it will be different. If you are using Azure's controller for your gateway API, it will be different. And this applies for storage as well. We saw that different vendors have exposed different parameters, typically managed by infra platform team for consistency, like we discussed before. Now let's talk about what is gateway. Provisions the load balancer defined by its gateway class. So what gateway is? Gateway is a logical configuration that results in a load balancer. I will leave this here, and in the next diagram I'm going to dissect this inch by inch. So for now, understand gateway is the logical configuration, and in gateway what you configure is you configure listeners, port, protocols, host names. And if I scroll down, you see gateway class name is Nginx, which is here. Listeners are, I am just defining HTTP 80 listener, which implies that the load balancer which will result because of this gateway manifest will be listening on port 80. Allowed routes, namespaces from all. So what I am saying is this gateway, the load balancer that will be resulting from this gateway can be serving applications that are deployed onto multiple namespaces. Again, this was a limitation with Ingress. With gateway, we can have applications deployed in different namespaces, use the same load balancer. But Varun, where is the load balancer? Load balancer will come in once you apply this manifest. And what sort of load balancer will that be? It depends on your controller, and we will see that in the next diagram. Third is links one or more routes to backend services, and we will see what I mean by this when I discuss this one. References a single gateway class for controller binding. Of course, you cannot have a gateway object reference multiple gateway classes. So here this one is using the gateway class that is named Nginx, and here is Nginx. And I want you to concentrate on one more thing here. Gateway class is cluster scoped. I have not defined any namespace in gateway class because gateway class is cluster scoped, but gateway and HTTP route, these are namespaced. Hence the namespace for gateway is Nginx Gateway Fabric Gateway API -ns. The last point is typically provisioned managed by cluster operators. This is what we discussed initially. Now the last one is what will connect all your dots. Route objects. If you remember, when we were dealing with Ingress, we were defining all the routes here, along with for this route send the request to this specific service. So for example, here we are saying that whenever request comes for /iPhone, you forward that to service named iPhone-svc, and this service is fronting a deployment that has pods that are catering to iPhone users, and we did that. And similarly, it's same. If you know the concepts, everything is same. So if you understand Ingress, Gateway API is a cakewalk for you. So if I go back here what I am saying, define routing rules. And if you see here, just concentrate on the rules here. I am saying what you have to match path is you have to match /iPhone, and if the request is for /iPhone, then the backend reference for that is iPhone-svc, and the cluster IP port for that service is 80. And this is exactly what we did in our Ingress. So the concepts are the same, and as you know, all these manifests can be seen in the documentation. You do not have to remember this. Now in HTTP route, you see I have defined a name, that is iPhone route. This is fine. And then I have a namespace. So understand that this is in app1 namespace. The gateway is in different namespace, and gateway class is cluster scoped. So you see what level of segregation we are achieving. Now my cluster operators will only have rights, authorizations on this namespace. I will not give them any permission in app1 namespace if I require that level of segregation. My application developers will not have any rights on this namespace, but they will have the rights on this namespace so that they can create HTTP routes or other routes based on their requirement. Supports HTTP, TCP, UDP, gRPC. We know these things, but in the example, I have only shown HTTP route. Forwards traffic to backend Kubernetes services like we have seen here, managed by application developers or service owners. It is this simple. Now I know with all this information you are still hazy that what each thing is doing. So to clarify all your doubts, what I have done is I have in the next diagram also brought in a controller so that all the dots can be connected. So I am calling this gateway API flow, controller, gateway class, gateway, and HTTP route. I hope this slide will connect all the dots for you. What I have here is I have a controller that is sitting here. Then I have the gateway object, gateway class object, and HTTP route object. Understand that these are here because we have installed CRDs for that, and we will be doing this in our demo section. As soon as you install the CRDs associated with Gateway API, you will see that you will have gateway class object, gateway object, and also the routes object. And routes, as I said, is an umbrella term. It will have multiple HTTP, TCP, UDP, gRPC, and so on. Then I have a control plane icon here with a brain symbol. What I'm trying to convey here is the controller acts as a brain. When you are talking about Gateway API, the controller is the brain for all things Gateway API related. Then you have a data plane at the top. Data plane is the one that is actually doing all the legwork. Why do I have deployment, daemon set, and a load balancer here? We will see that in a little while, but for now just understand that these are all your options that are available at your disposal. Now what I have also done is I have also done a marking here: 1, 2, 3, 4, and 5. Now why I have done this? I have done this so that you can have some sequence to understand these concepts in a better way. So now let's understand what I want to discuss. Firstly, see, all the arrowheads are pointing to gateway, gateway class, and HTTP route, and the origination of these arrows is from the controller. So I want to make this point very clear that controller is watching everything, and that is the job of the controller. Controller will see everything, and based on whatever you have configured in these manifests, it will take action. So it is imperative to understand that controller is the brain for everything in Gateway API. So the Gateway API controller is the brain for everything associated with Gateway API. Now I want you to know that whenever you configure a controller, a associated gateway class automatically gets installed, and if it is not installed, your specific Gateway API controller vendor will tell you that you have to create a gateway class, and these are the specifications for that. I want you to clearly understand that there are multiple vendors who are providing gateway API controllers, and Nginx is one of them. You would see the cloud providers have their own gateway API controllers. Traffic will have their own, Envoy, Istio. All of these have a gateway API controller offering with them. In this diagram, I am using Nginx's gateway API controller. Now, what happens is Varun walk into this cluster, create a gateway resource. As soon as the controller sees that there is a gateway resource, it will see, okay, the gateway class name is Nginx. Where is Nginx? Nginx gateway class is here. Oh, I am the controller who is responsible for this gateway class. So let me do something about it. Let me create a data plane. Now, data plane, what is the data plane? Data plane is something that will do the actual legwork. And what is that legwork? Legwork is routing. When the request is received for iPhone, send it to the iPhone service. If the request is for Android, send it to the Android service. That is the legwork. Then Varun, what is the control plane doing? Control plane is the one that is ensuring all these things are done, because control plane, which is not you are defining these configurations, but the control plane has coding, and that coding is done by your vendor who is deciding how to take care of these requests. You, as a Kubernetes administrator or a developer or a DevOps engineer, is just ensuring you write the manifest based on the specifications that are defined in the documentation of Kubernetes. So as long as you adhere to these specifications, your manifest can be interpreted by the controller and actions can be taken based on that. So let's get back to our topic. Whenever Nginx sees, okay, there is a gateway manifest, let me spin up the data plane layer. Now, what will Nginx controller do? Nginx controller will create some proxy servers. Now, these are reverse proxy servers that will act as actual load balancer and will be load balancing the request for you. And what are these? These are just pods which are part of a deployment. Now, what these pods will do, we just now discussed that these act as proxies and will be sending the request to the required service, and these proxy pods will be listening on the port that you have defined here. But Varun, if my load balancer logic is inside my cluster, then how can someone from outside access it? So there are two options here. Either you can use node port, which is not recommended because your nodes come and go, their IP change, or you can place a layer 4 load balancer. So how the flow will look like is, in your DNS provider, you will create a DNS record that whenever the request comes for this website, you send it to this load balancer, and that load balancer is your layer 4 load balancer, which in turn will be sending the request to these proxy pods, and from there the request goes to the service that is responsible for that request. Now we will see this entire flow in our demo section, but for now I just want you to have the idea how the controller fits in into the bigger picture. But Varun, why have you shown a daemon set and a load balancer here? Again, it depends on the controllers. Now the Nginx's gateway controller spins a pod that are part of deployment, but your specific implementation, maybe you are using Traffic, Envoy or Istio, they could be using a daemon set as well. That is why I have also shown a daemon set in the data plane. Rest everything will remain the same. There will be a load balancer that is sitting outside that will be forwarding all the requests to your daemon set, and this is the Kubernetes load balancer service that I am talking about, which will result in a layer 4 load balancer in your cloud, or you could be using Metal LB if you are in an on-premises setup. And there are multiple other options. Then what is this load balancer doing here? Now here I am using Nginx gateway controller. If you were using, let's say, AWS's gateway API controller, or Azure's gateway API controller, or GCP's gateway API controller, then they will be spinning some sort of load balancer. For example, if I talk about AWS, they will spin something called VPC lattice. Azure will spin up a load balancer, so will GCP. Hence, I have shown this load balancer. And that load balancer will, of course, have the configuration that you have defined in your gateway. Now, why have I mentioned this as a fifth point? I want you to clearly know that this gateway controller is constantly looking for this gateway resource, and as soon as it sees this, it will create a load balancer as soon as it sees it. But you have not yet configured the routes, so it will just spin this load balancer. But when you create this, and I want you to concentrate on this manifest, this manifest says that my parent reference is name is gateway. And whose name is gateway? Gateway is here. That's my parent reference for this HTTP route, because this is in a different namespace and this is in a different namespace, and controller checks that the parent reference for this HTTP route is this gateway, and then this parent reference, this name, is part of this namespace. And if you see, the namespace for this is Nginx Gateway Fabric Gateway API NS. And understand, this HTTP route, this object resides in app1 namespace, but its parent reference is something that is outside its namespace. That is the beauty of Gateway API. It provides you with proper role separation and segregation. And at the very last here, we have the rules defined. Hence, HTTP route and gateway, the reconciliation of all these things is done by the controller. You see, binds routes to listeners, and listeners are here, watches for gateway API resource, and this is here. Understand that controller is responsible for reconciliation. It keeps looking for all these things, and once this is done, it configures your load balancer or your proxy pods that are part of deployment or daemon set accordingly. Again, what will happen here depends on your controller. Clearly keep this in mind. Read the documentation. It is not one size fits all. In on-premises, you will have a different design. In self-managed clusters on cloud, you will have a different design. In managed Kubernetes services like AKS, EKS, or GKE, you will have different design. So keep that thing in mind. Now, cloud managed. So when you are in cloud, and this is important, okay, the request first is initiated by the client, then is reaches the cloud load balancer, and from the load balancer directly to the Kubernetes service. So understand, in this design, our proxy pods, our reverse proxy pods are part of a deployment, and hence they are inside the cluster. But when you talk about cloud, the controller, I mean, if you are on Azure, if let's say you are cloud managed, and if you are using Azure, the load balancer will be spun out. In that scenario, you won't have any proxy pods running in your cluster. Hence, the request from cloud load balancer will directly go to the Kubernetes service and then to the backend pods. But when you are using in cluster design, like I have on my screen here, you will see that the request will be initiated by the client. It will go to the load balancer or node port service. This load balancer service will create a layer 4 load balancer in cloud. Then it will go to the proxy pods, and proxy pods are the ones that have where to send the request, and hence they will send the request to the appropriate service, which in turn will send it to the appropriate backend pods. I hope this is understood. I think that is all I wanted to cover in this theory lesson. That wraps up part 1 of our Gateway API series. We have laid the groundwork from understanding the limitations of Ingress to breaking down the Gateway API resource model and its traffic flow. In part 2, we will bring it all together with a live demo using Nginx Gateway Fabric so you can see exactly how these concepts translate into a working setup. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.